All right, here are the notes for 8-4. We had just talked about the tangent button. Now we're going to hit the sine and cosine button. And the procedure is essentially the same as the tangent button. Obviously, we're dealing with triangles, right triangles. There's three sides to a triangle. With the tangent button, you only dealt with the opposite and adjacent. Well, there's also the third side, and that's the hypotenuse. So the sine and cosine buttons deal with the hypotenuse. So sine is opposite side over hypotenuse. Cosine is adjacent over hypotenuse. And so again here, sine, we can abbreviate it, and I'm skipping some of this, is opposite over hypotenuse, and cosine is adjacent over hypotenuse. There's an acronym that we use for trigonometry. It is SOHCAHTOA. SOHCAHTOA. Kind of like, please excuse my dear Aunt Sally, parentheses, exponents, multiplication, division, adding, subtracting. Well, this stands for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. SOHCAHTOA. Okay, so when we bump into one of these problems, you've got to choose correctly. Is it going to be sine, is it going to be cosine, or is it going to be tangent, which of course is opposite over adjacent. Here we go with the number 1. This is just going to write a couple of ratios here. Write the sine and cosine ratio for angle x. So we're just going to say sine angle x is equal to something, and we'll figure that out in a second. Cosine of angle x is also equal to something here. Now sine again stands for opposite over hypotenuse. If you stand here at angle x, opposite to angle x is the 64. Hypotenuse is always opposite the 90 degrees, so this is always the hypotenuse, and that's 80. So 64 over 80. If you talk about cosine of angle x, start at the angle. Cosine now stands for adjacent over hypotenuse. If I stand here at angle x, adjacent to it is the number 48, and the hypotenuse, as we just mentioned, is opposite the 90, and that's 80 in this picture. So we didn't do anything. We don't need a calculator. We just stand at an angle, choose 2 of the 3 sides of the triangle, and set it up according to the trig function that you choose. All right, here we go with number 2. The angle the wire makes with the ground is 50 degrees. So this is a wire here. What is the height of the flagpole to the nearest foot? So there's a flagpole here. This will be x, because that's what we're trying to figure out. What is the height? Anything you don't know, you let it be x. This is the wire. It's 20 feet long. We're going to figure out what x is. Now we're going to have to choose. Is it going to be sine, cosine, or tangent first? The previous work, it was always tangent, but now we have to choose between sine, cosine, or tangent. So you always stand at the angle that they give you, and you've got to see, well, what sides do they have available here? We have opposite. That's what we're going to try to figure out. Opposite the 50 degrees, we have opposite the 90, so this is the hypotenuse. And this side here is the adjacent, but if you notice, there's nothing here with the adjacent. There's no number here. We're not trying to solve it. So really, we don't need the adjacent for this one. So we are dealing with the opposite and the hypotenuse, and that is sine. Okay? So don't always just take tangent. You've got to choose correctly. So we're going to say sine, then the angle, 50 degrees, is equal to, sine now stands for opposite over hypotenuse. So opposite x over hypotenuse 20 feet. And that is your basic setup. After this, the calculator does all the work. But you've got to get the correct setup here. So we'll go sine of 50, and that is 0.7660 is equal to x divided by 20, and then multiply by 20. And so the flagpole is about 15.3 feet, or 15 feet if you were rounding it to the nearest foot. So if this is 20 feet, then this flagpole would be 50 feet. But again, you start at the angle, decide which of the trig functions to use. Is it going to be sine, cosine, or tangent? SOHCAHTOA. opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Let's take a look at this next one here. Find the value of x. Now notice x is the angle and round it to the nearest degree. You have two of the side lengths here that relates to x. This 6.5 is opposite. This opposite the 10, opposite the 90 is the hypotenuse. There's nothing here in the adjacent, so we don't even worry about it. So which one deals with opposite and the hypotenuse? That again is sine. So we're going to say sine of the angle is equal to opposite 6.5, go across from the x and then over the hypotenuse 10. This is a missing angle, and whenever you have a missing angle, this is where you do the inverse button. Look for this inverse button in the calculator, the -1. 6.5 over 10. Okay, so what we're going to do here, we're going to go second sine, and then you got that -1 showing up here. Then you tell the calculator, I've got an opposite side that's 6.5 inches, I've got a hypotenuse that's 10 inches, and the calculator is going to tell you, okay, well, if that's what you have an angle that is 40.5 degrees. Or you could say 41 because they want to round it to the nearest degree. 41 degrees, okay? So it knows, the calculator knows, if you are talking about the opposite number and the hypotenuse, that's 6.5 and 10, you must have a 41 degree opening that creates that relationship.